All right, so what I got is a little review on formula writing and naming. So a couple things. So binary compound, so binary means having two parts, right? So for binary ionic compounds, for naming the metal keeps its name. Well, that it is. And the nonmetal gets an "ide" suffix. Right. So if you have your periodic tables ready, it would be helpful. For this assignment, you're doing the odds, right? Or you're doing the evens, right? So let's work on some evens first. So the first one, NaS. So if we come to our periodic table over here, we'll see that Na, which is right here, and S, which is over here. Right? So Na is sodium. Make it smaller again. And the S, which is sulfur, becomes sulfide. Right? So you could do the same thing for number 4, and CS is right here, and I is over here. So if you look those up on your periodic table, you get cesium, and I is iodine, but we change it to iodide. Right? There's an extra I in there. I don't know why, and I'm having problems with my pen. So cesium iodide. All right, so for writing formulas, we have to do it a little differently. So writing formulas, we need the charges. So I'll do a little review here. So if you remember the periodic table for ionic compounds, metals lose and nonmetals gain. So we have our step over here, right? So everything to the left of the step is a metal, and they all lose electrons or become positive cations. And everything to the right tends to gain electrons, right? So these all lose electrons. And these all gain. Right, they all gain. So metals will lose to get to those noble gases. So it's important to remember this first group will lose 1 electron, so those become positive ions. Oops. I'd rather write it like this. Hold on a second. This next group, because they're 2 in, will lose 2 electrons, become 2 positive ions. Starting at aluminum here, they'll become 3 positive ions, and it really accounts for aluminum, gallium, and indium, right? And then everything else in the middle. So if we go this right here, these are all transition metals, and they all have multiple charges. We'll talk about those later. Okay, so these can have multiple charges. Those can all have multiple charges. Now the nonmetals will gain electrons to get to the noble gases. So if you look at nitrogen here, it needs to gain 1, 2, 3 to get to neon. So nitrogen will be 3 negative, oxygen will be 2 negative, and then the halogens will just be negative. We don't usually write the ones, and there's a reason for it. So if you think about that, if you remember that and you've got your periodic table, it would be very helpful. Right, so if we look at the homework now, potassium nitrite. So the first thing we're going to do is write our element, so K for potassium, and for nitride. So if you look at potassium, it's in this first row here, right? Let me change colors there. So if we look at potassium, it's in that first row there, and nitride was over there in the third row. So potassium has a positive charge, and nitride will have a 3 negative charge because it needs to gain 3 electrons. Now, if you remember the whole crisscross thing, I will bring the number of the charge to the element, so I'll end up with K 3N. Because what that does is if I bring that 3 down here, it means I have 3 potassiums, right? And so I'll have 3 positive charges, which will cancel out my negative charge. And then my overall charge of this will be 0. So we don't include any positives or negatives. So if we look at strontium fluoride, same thing, right? So SR is in the second column, right? So if we look at here, SR is right here, second column. And then we're looking at strontium fluoride, and fluoride is over here in the 7th column. Okay? So strontium, strontium, I didn't want that. Let me erase that. And then fluoride. So since strontium's in that second column, it'll have a 2 positive charge, and fluoride will just have a negative charge. So same thing, I want to crisscross them. And I'll end up with SR, F, and 3 because I brought that, or F2, sorry, because I brought that 2 from strontium down to the fluorine. Okay? So pretty easy. So when I deal with transition metals, right, I need to look at the charge. So I kind of got a backwards crisscross transition metals. All right, so what we'll have here is, we'll work at this first one. So mercury iodide, right? So iodide, each iodide, if I look at here, it's in the last column of my periodic table. So each iodide has a negative charge. But since I have 2 iodides here, if you can, let me make that a little bigger. Since I have 2 iodides there, I have a total of 2 negative charges because I have 2 of them. So that means mercury would have to have a 2 positive charge, right? So the rule with these transition metals is you must include a charge number. Okay? So you must include a charge number. So this would be mercury 2 iodide. Right? And that 2 is that charge number because it says it has a 2 positive charge. Right? So same thing. 10, if you look over here, right? So 10 SN is kind of in that transition area there, right? So we'll say 10, and then F is fluoride, because fluorine becomes fluoride, right? And we know that each fluoride has a negative charge. So same thing, since each fluoride has a negative charge, I have 2 negative overall charge. So 10 would have to have a 2 positive charge to cancel it out. So it becomes 10 2 fluoride. Right. If we keep going down to gold oxide, right? So now we're just writing formulas. So remember that the charge number here tells you the charge. Right? So if you come there and then we come find our oxygen, right? And our oxygen was right over here, right? It's in that 2 negative column because it needs 2 electrons. Gold is Au, right? And then oxide is O. So we said this Au has a positive 1 charge because it was gold 1. And oxide is a 2 negative charge because it's in that category. And if I crisscross again, that 2 would come down to the gold. And then O would be by itself. All right, so you should be able to do number 16 same way. When we name nonmetals, just to remind you, when we name nonmetals, so nonmetals, oops, I'm in a place where it won't let me write. Must use Latin prefix, so one is mono, but I'm going to say that's not on first element. Two is di, 3 is tri, 4 is tetra, penta, hexa, oh, I lost my pen again. Hepta, octa, nona. So those are my prefixes, right? So if I was going to name these, and covalent means all of nonmetals, so there's not any metals in there. So make sure before you're naming these, there are not any metals. So if I come to 18, so S was sulfur, and O, remember, was oxide because it ends in "ide." But since there's 2 of them, I have to use my prefix. My prefix for 2 is di. If we come down to 20, it still starts with sulfur. Remember, I wouldn't use mono because it's the first element. And then there are 6 fluorines, right? So 6 is hexa. And fluorine becomes fluoride because it gets that "ide" suffix. All right, so pretty easy. Now we come to what are called ternary compounds, or things that include polyatomic ions. Now remember, a polyatomic ion is a group of nonmetals with a charge. Okay, so you have a polyatomic ion sheet. It is right over here. I'm trying to get it so I can move it. I'll put it over on this side. Okay, so you have a polyonic sheet here. I'm trying to make it smaller, but it won't let me resize it. Huh. I don't know why. It won't let me resize it. All right, so I'll just do it this way. All right, so the best thing to do is look at your polyatomic ion sheet. Remember that polyatomic ions generally end in 8 and I. So same thing. The metal keeps its name, and the polyatomic ion keeps its name. So if you look at your periodic table, so Na was sodium. And PO4, right? So if I look down here, PO4, let's just find it. Oh, it's right there. So it's phosphate, right? Okay, so that's the way it works. If I look at the next one, 24, Mg is magnesium. And I have OH, and I just look on my list here, and I'm looking down. And OH, I found it right here. It's called hydroxide. So that's essentially the way that you do that. Okay. Now, if I was going to make my formulas, potassium hydroxide, I do the same way. Potassium I know is K. Then hydroxide, remember I found right here. That's OH. And that OH has a negative charge, I'll see there. And potassium has a positive charge in the periodic table. So since my charges cancel out, it would just be that. 30, if I do nickel 3 sulfate, Ni is nickel. And since it's nickel 3, I know it has a 3 positive charge. And sulfite, I'm sorry, not sulfate, but sulfite. If I come down and look here, and I find the word sulfate, and I don't see any sulfite, right? But the thing is, 8s and ites, so 8s and ites. So ite means one less oxygen. So if sulfate is SO4, oh, here's sulfite on top. Sorry, I didn't see it. Right, but just in case. So sulfite, SO3, it's 2 minus. So now I'm going to have crisscross. So that 2 from sulfite comes in nickel. So Ni2, right? And then SO3, I'm going to have to put that in parentheses. I'm going to bring that 3 from nickel, and it has to go on the outside, right? So that's the way you would do that, all right? And you can do 32 by yourselves, and you can do the combination section, all right? So hopefully this is helpful if you can't remember after I talk to you today.